Hi, name Rajiv Majumdar, role 63. Our topic is classification of signals. Let's see what is signal. A signal is a function that carries information about how a physical quantities change with respect to one or more independent variables like time, space, distance, temperature. Some examples: voltage in a circuit over time, daily temperature reading, audio waveform of a song. And you can see various examples here. There's our first type of signal, continuous time and discrete time. What is continuous time signals? If it is defined for every instant of time t in a given range, then it's called a continuous time signal. Example, xt equals to sine 2 pi t, sound wave, temperature variation over the day, continuous as the graph, continuous graph, notation xt, discrete time signal. If it is if it is defined only at a specific discrete time instant, notation xn. Here's n is the integer xn. Example, xn equals to 22468. Another example is daily temperature recorded at 8 a.m. each day, not the total day data. It is just 8 a.m. as the graph discrete. You can see we can't find any value between each steps. Okay, next, deterministic signals and random signals. A signal whose values at any time can be exactly determined using a mathematical formula. That means we can find the signal, or we can represent the signal with a mathematical rule or mathematical formula. Real life examples: voltage output of a stable sine wave generator. You can see the graph. It's kind of see the sine wave graph. It can be anything, but we can we should or it should be represent in a mathematical form. Random signal. A signal whose values cannot be exactly predicted, only uh, statistical properties like mean variables are known. Example, ECG signals with noise temperature variation. As the graph is, you can see we can't represent it in a mathematical formula. It's hard. We can't. Periodic signal. If it is repeat itself after a fixed interval t, capital T, called the periodic signal. Mathematical condition, xt equals to x small t plus capital T is time periodic. For discrete, it's represented like this. If you see example, AC main voltage waveform, or you can see a sine graph with period. Aperiodic signals. A signal is a aperiodic if it is does not repeat over time. Mathematical condition, it does not repeat itself, so xt not equals to x multi plus capital T. Examples, exponential power minus t, speech waveform of a conversation. You can see the graph, it doesn't repeat itself. And here in periodic signals, after capital T, the graph is repeating itself. Even signal and odd signal. If it is symmetric about the vertical axis, xt equals to x minus t, it's equal. It's for continuous. For discrete, this. A note mirror image around t, 0 in graph mirror image. You can see this. Example, xt equal to t square, a parabolic graph. It's symmetric about the vertical axis, and cosine graph, it's also symmetrical, and I'm draw a cosine graph here. Odd signal, if it is antisymmetric about the vertical axis, antisymmetric about the vertical axis, then it's called odd signal. And the equation there, xt equals to minus x minus t. And for discrete example, xt equals to t and xt equals to sine graph. Next type of signal. Before next type of signal, let's see some properties or notes. Any signal can be expressed as a sum of odd and even signal. Xt equals to xe plus xo, where xe is half of xt plus x minus t. And some properties: for even signal, odd part is 0; for odd signal, even part is 0. And you can see the more properties here. Next part, energy signal and power signal. A signal is an energy signal if it is has finite energy and zero average power. That means we have a finite num we have a finite value of energy, but don't or we don't have a value of power. Is the value of power is zero. Discrete For discrete, the equation is this, and for continuous, the equation is this. Examples: signal pulse of finite duration, Gaussian pulse, exponential power minus t squared. Graph is here. Power signals. A signal is a power signal if it has finite non-zeros average power and infinite energy. And that means the power has a finite value and the energy has infinite value. Infinite value is infinite. Okay, infinite energy. Okay. The graph, example, a sine graph, infinite sine wave. Next, our last type of signal is casual signal and non-casual signal. A signal is casual if it is 0 for all negative time, 0 for all negative time. The example, xt exponential power t ut. Step signal. Step signal is a example of casual signal. You can see the graph. It don't have a it don't have a mm, value at negative part of t. Non-casual signal. A signal is non-casual if it has non-zero non-zero values for negative t. You can see if we can find anywhere in the graph value. So example is xt e to the t for all t and cosine graph. It's also some example like sine graph, any graph that can represent minus t and plus t also. Okay, we end our discussion here. Thanks for the opportunity to present class.